We make decisions all the time, consciously or not. In studying statistics, making decisions based on observations or data that are considered random variables is an essential concept to learn. Such procedure of making decision is called the hypothesis testing. One of the goals of every nation is to produce professionals who will contribute to scientific knowledge through research. And in research investigation, hypothesis testing is a vital procedure. It is making a decision whether to accept or just to reject a statement of the assumption about the parameter in the research problem. From the result of the correct decision making, conclusions are drawn in which facts are generated and thus can become a contribution to a particular body of knowledge in the fields of education, or it can be in business, medicine, economics, and many others. In this lesson, we will run through some basic concepts needed for hypothesis testing and study steps in conducting it. So, from the previous video you've watched already, this lesson will be basically its continuation. To define it formally, hypothesis testing is a decision-making process for evaluating claims about population. It aims to make a statistical conclusion about accepting or not accepting the hypothesis, and the best way to determine if a hypothesis was true would be to examine the entire population. So these are the steps in conducting hypothesis testing. The first one is to state the null hypothesis and the alternative hypothesis. Our null hypothesis is usually denoted by H sub 0, while our alternative hypothesis is denoted as H sub A or H sub 1. Next one is to choose the level of significance and the sample size. Usually, our level of significance is denoted by a Greek letter alpha or beta depending on the type of error, and our sample size is usually given. Number 3, determine the test statistic and the sampling distribution. So this part, we're just going to define later on the test statistic and the sampling distribution in order for you to understand it deeply. Number 4, determine the critical values that divide the rejection and non-rejection regions. So later on, we're going to study where is the part that said that it's a rejection and for non-rejection regions. Next, number 5, collect the data and compute the value of the test statistic. Number 6, make a statistical decision, and of course, in every process, there is an ending step for us to state the conclusion. From the previous video, statistical hypothesis was well discussed already. So in this slide, we're just going to run through its basic definition. So when we say statistical hypothesis, these are the statements that said to be on assumptions, conjectures, or guesses, which may or may not be true about our population parameter. So these claims are needed to be proven through our hypothesis testing in order for us to accept or to reject that statement about the population parameter. And when we say population parameter, these are the measures that describe our population. Here are some examples. 1. The average adult drinks 1.8 cups of tea per day. 2. 13% of high school students in Australia will go straight to university. 3. The mean income for a resident of Denver is equal to the mean income for a resident of Seattle. So as you can see in number 3, I already mentioned here what will be our population parameter, and that is a mean income. Population parameter again is a measure that describes our population, and the population in this example consists of residents of Denver, while the other consists of residents of Seattle. As you've observed, 1, 2, and 3 are all assumptions or simply conjectures that needed to be proved through our hypothesis testing to accept it or to reject it. There are two kinds of a statistical hypothesis. Let's have a short recap about null hypothesis. This is denoted as H sub 0, and this is the hypothesis that needed to be tested. So this is the statement that we decide if whether we're going to accept or to reject. And it represents a status quo, and this hypothesis states that there is no statistical significance difference between two variables in the hypothesis, and these two variables are the population parameter and the value that is being claimed. So now let's look at the picture at the right side of this slide. So as you can see, this picture shows a trial. Ito yung usually nating nakikita or naririnig sa mga trials. It's either in the movie or in the real life. Sinasabi na the accused here is presumed innocent until proven guilty beyond all reasonable doubt. So we presume that the null hypothesis is true and must prove otherwise. Because in the null hypothesis, we believe this to be true unless there is overwhelming evidence to the contrary, or simply the hypothesis that the researcher is trying to disprove. Example, it is hypothesized that flowers watered with lemonade will grow faster than flowers watered with plain water. So in stating our null hypothesis, there is no statistical significant relationship between the type of water used and the growth of the flowers. So in other words, the type of water has nothing to do with the growth of the flowers. The second kind of a statistical hypothesis is called the alternative hypothesis, denoted as H sub A or H sub 1. This is the inverse of the null hypothesis, and it holds true if the null hypothesis is rejected. And this is a statement saying that there is a significant difference between the population parameter and the value that is being claimed. An alternative hypothesis, this is usually what the researcher thinks to be true and is testing. Because of this, the alternative hypothesis is sometimes called the research hypothesis. Let's have this example from the previous one. We say that the null hypothesis, if one plant is fed lemonade for 1 month and another is fed plain water, there will be no difference in growth between the two plants. But in alternative hypothesis, we need to claim our side. So it's either it's either the water do best for the growth of the plants or it's the lemonade. So in our alternative hypothesis, we took the side of the lemonade. So if one plant is fed lemonade for 1 month and another is fed plain water, the plant that is fed lemonade will grow more than the plant that is fed plain water. And now let's go with the first step of the hypothesis testing called the stating the null and alternative hypothesis. So I have here two examples. So let's have example number 1. The editor of the publishing company claims that the mean time to write a novel is 16 months. 40 randomly selected authors of novels said it is more than 16 months. Each of them said it takes 18 months to write a novel. So let's reveal our null and alternative hypothesis. So for our null hypothesis, mean is equal to 16. So this number came from the claim of the editor of the publishing company. While our alternative hypothesis, our mean must be greater than 16. So this claim came from the 40 randomly selected authors of novels. So they say that this is more than 16 months. Okay, next, let's have example number 2. The principal of the school claims that the mean age of the teachers is 45 years. The mean age of the 35 randomly selected teachers is 42 years, which is not equal to what is claimed by the principal. So let's reveal our null and alternative hypothesis. Null hypothesis, mean is equal to 45. So this 45 years was claimed by the principal of the school, while our alternative hypothesis, mean is not equal to 45. It is the claim of the 35 randomly selected teachers that said to be it is 42 years. So this is obvious yung difference between our null hypothesis and the alternative hypothesis. So I have here a note. Our null hypothesis will always have an equal sign and possibly a less than or greater than symbol depending on the alternative hypothesis. And the alternative hypothesis is a range of values that are alternative to the one in our null hypothesis. Rejection region, critical values, and level of significance. With a given example, sample mean is the value obtained by randomly selecting group of people to gather a value called mean. while test statistic is a numerical value obtained from a statistical test. So meaning if the researcher needs to convert the sample mean to a value that is called the test statistic, it needs to undergo a statistical test. And this test statistic will be the basis to make a decision and draw a conclusion. So with this given illustration, you're going to understand how these regions works. So we have two regions. This is called rejection region, or sometimes it is called critical region. And the second one is the non-rejection region. This is also called non-critical region or the acceptance region. So these two regions is separated by a critical value. So later on, I'm going to teach you how to compute for a critical value. But the deal here is, for example, I have a critical values which are negative 1.5. Okay, this is hard. And this one is positive 1.5. Let's say this is positive 1.5. So if the test statistic, again, yung test statistic is from a sample mean, nag-undergo lang siya ng statistical test, is negative, for example, negative 1.7. So meaning this is less than our critical value, so it will fall under the rejection region. So ano bang ibig sabihin nun? If the test statistic or computed value falls in the rejection region, or it falls beyond our critical value, then the null hypothesis is rejected. E paano naman kung hindi siya nag-fall under the rejection region? So, for example, our test statistic is negative 6/10. So, obviously, 6/10 will fall within the range of negative 1 and 5/10 and positive 1 and 5/10. So, meaning, yung opposing conclusion yung kukunin natin. So, since negative 600 falls in non-rejection region, so papalitan natin ng non-rejection region, meaning, the null hypothesis is accepted. So, that's how that rejection region and non-rejection region works. So, later on, we're going to have another example. So now let's have the type 1 and type 2 errors. What is the difference between the two? When we say type 1 error, it occurs if one rejects the null hypothesis when it is true. And the probability of committing type 1 error is called the level of significance alpha. While type 2 error occurs if one does not reject the null hypothesis when it is false. And the probability of committing type 2 error is represented by a Greek letter beta. So I have here a table that shows a decision and the true state of nature. So this is how you read this. When your null hypothesis is true and you reject that null hypothesis, you are committing a type 1 error. But if your null hypothesis is true and you accept that null hypothesis, meaning you are making the correct decision. And in this case, if your null hypothesis is false and you reject that null hypothesis, you are making the correct decision. But if your null hypothesis is false and you accept that null hypothesis, you are committing a type 2 error. And let's have now a quick run through about two-tailed and one-tailed test. So when we say two-tailed test, the null hypothesis should be rejected when the test value is in either of the two critical regions. And two-tailed hypothesis test is used whenever the alternative hypothesis is stated as not equal to. So, meaning the alternative hypothesis contain the sign of not equal to, and the two-tailed tests are non-directional. So, with this given illustration here, so we have two parts of the rejection region, left and right side. So now let's have the one-tailed test. I know this topic is already discussed from the previous video by Ma'am Engay. So let's just have a quick recap about this. So as you can see, our Alternative hypothesis contains the sign less than and greater than. And when we say one-tailed test, this is directional. Okay, so I have here two figures. So the first one, our alternative hypothesis contains the less than sign. So meaning the rejection region or the shaded part in here is in the left side. And this is called left tail test. Okay, next we have this figure, and our alternative hypothesis contains the greater than sign, meaning the shaded part will be at the right side, and this is called the right tail test. So now let's have this example. We're going to find the critical value for the test of significance in each of the given information. Letter A, we're going to have a two-tailed test, and our population variance is known, given that our level of significance will be 500 or simply 5%, and our n is equal to 35. If the test is two-tailed, we're going to divide the level of significance by 2. Then we're going to subtract its quotient from 5/10. So by the given that we have 5/10 minus 25 thousandths. So in here, why 25 thousandths? Because 500s divided by 2 is equal to 25 thousandths. And now we have 5/10 minus 25 thousandths is equal to 4,750 10,000ths. And this amount will be the area under the normal curve that we're going to look for to find our critical value. So since the variance is known and n is greater than 30, we're going to use the table of areas under the standard normal curve. So in here, we have the areas under the standard normal curve. So we have here 4,750 10,000ths, and the area of this is under column headed 6. So we're going to move along this row to the left until 1 and 9/10 under column headed is reached. So if you're going to ask what will be the critical values, so that would be 1 and 9/10 plus 600ths, that will be equal to 1 and 96/100ths. Therefore, in this example, at 5% level of significance, the critical value is positive and negative 1 and 96/100ths. So meaning, values greater than 1 and 96/100ths and less than negative 1 and 96/100ths will fall under the rejection region, while values in between negative 1 and 96/100ths and positive 1 and 96/100ths will fall under the non-rejection region. Next, letter B, we have the one-tailed test. Our population variance is known, while the level of significance is the same, so that is 5%, and n will be equal to 14. So since the variance is unknown, take note of this, the variance is unknown, and our n is less than 30, or the sample size is less than 30, we're going to use the table of T critical values. So now we need to know first what will be the sample size, and that is 14. Why? Because we're going to compute for the degree of freedom. Again, this is degree of freedom. And degree of freedom will be obtained by this solution, which is n minus 1. So sample size minus 1, that would be 14 minus 1. So the degree of freedom will be 13. And of course, the test is said to be one-tailed. So by this given, we have the degrees of freedom of 13 and the level of significance, that is 500ths, and we say that this is one-tailed. Let's look after the T critical values. So in T critical values, we're going to locate 13 and headed our degrees of freedom. So 13, so obviously this will be the one value that we're pertaining, because with the levels of significance of 500ths under the one-tailed, refer to the column indicating an area of 500ths in one-tails. So this will be the arrow and the critical value will be 1 and 771 hundredths. So in example letter B, the critical value is equal to -1 and 771 thousandths if it's left tail, while the critical value is equal to +1 and 771 thousandths if it is on right tail. There is an appropriate test statistic for hypothesis testing about the population mean. So when the population variance is known and our sample size is greater than or equal to 30, we're going to use the Z statistic. And this will be equal to the sample mean minus the population mean all over the population standard deviation divided by the square root of our sample size. But if the population variance is unknown and our sample size is less than 30, we're going to use the T statistics, and this will be equal to the sample mean minus the population mean all over the sample standard deviation over the square root of the sample size. We have two variations of method when it comes to hypothesis testing. One is the critical value method. If the computed test statistic falls within the rejection region, we're going to reject the null hypothesis and accept the alternative hypothesis. While in the p-value method, if p-value is less than or equal to our level of significance, we're going to reject our null hypothesis. But if our p-value is greater than the level of significance, do not reject our null hypothesis. So let's have this example. It is claimed that the average weight of babies at birth is 3.4 kilograms. The average weight of the random sample of 30 newly born babies was found out to be 3.1 kilograms. Is there a reason to believe that the average weight of babies at birth is not 3.4 kilograms? So now we're going to assume that the population standard deviation is 1.1 kilograms and we're going to use the 500ths level of significance. So the first step in hypothesis testing will be to state the null hypothesis and the alternative hypothesis. So in this solution, we're going to use the critical value method. So the null hypothesis here will be mean is equal to 3.4. Why? Because it is first-hand claim that the average weight of the babies at birth is 3.4 kilograms. Next, for our alternative hypothesis, that would be mean is not equal to 3.4. It says here that the average weight of a random sample, okay, take note of this, a random sample of 30 newly born babies was found out to be 3.1 kilograms, and 3.1 kilograms is obviously not equal to 3.4. Next is to determine our level of significance. So it's already given in this example that our level of significance is 500ths. Okay, next. Since the population variance is known and our sample size is greater than or equal to 30, since our sample size in this example is equal to 30, and this is said to be equal to 30, sample size is equal to 30, we're going to use the Z statistic. And the formula for Z statistic is this. Okay, we have the sample mean minus the population mean over the population standard deviation divided by the square root of our sample size. So we're just going to substitute the given values. For the sample mean, we have 3.1. So dito siya nanggaling sa random sample of 30 newly born babies. Minus our population mean, which is 3.4, divided by 1.1. This is our standard deviation or the population standard deviation divided by the square root of the sample size, which is 30. So by conducting or performing our operations, we're going to have the answer of -1 and 494 thousandths. And this value is the one that is being claimed ng ating example. Okay, so number 4, we're going to determine the critical values to set our rejection region and non-rejection region. So since our alternative hypothesis is non-directional, bakit siya non-directional? Because in alternative hypothesis, we use this unequal sign, and this is set as non-directional. So since, again, this is non-directional, we're going to use the two-tailed test. Okay. So after using the two-tailed test, you all know how to get this critical values. So para ma-refresh lang ulit, all we need to do is to divide our level of significance by 2. Then its quotient will be subtracted from 0.5, and this will be it will be resulting to 0 and 4,000. 4,750 10,000s. And this one will fall under dun sa ating areas under the standard normal curve into positive and negative 1 and 9600. So this will be the critical value in the graph of our normal curve. So anything that is greater than positive 1 and 9600s will fall to the rejection region. Same as any number less than negative 1 and 9600s will fall to our rejection region. So again, the value that we're going to have is negative 494 thousands. And obviously, this value will fall within the acceptance region or sa non-rejection region, kasi this is in between the interval of negative 1.96 hundreds and positive 1.96 hundreds. So the thing is, we're going to accept the null hypothesis. So our conclusion, the average weight of the babies at birth is 3.4 kilograms. So same problem, we're just going to use the p-value method. First step, stating the null hypothesis and alternative hypothesis. So null hypothesis is mean equals to 3 and 4/10. Alternative hypothesis is mean is not equal to 3.4/10. Okay, next, number 2, level of significance, 500s. So since the population variance is known, and again, n is greater than or equal to 30, we're going to use the z statistic. And just like what we did earlier, merely substitution, and we have this value, which is negative 1 and 49. So, renound off lang natin siya to the nearest hundreds. So, next, since our alternative hypothesis is non-directional, we're going to use the two-tailed test. Always remember that. Take note of that. Okay, since our z statistic is equal to negative 1 and 4900s, we have the area of 4,319 10,000. So, saan ba natin na-obtain diyan? So, this is from the areas under the standard normal curve of 0 to z. So, again, we have the 1 and 4,900. So, look at this row. We have the 1 and 4/10, and this one we have the 900. So when you add it, you're going to come up with 1 and 4,900. And this is having this value, which is 4,319 10,000. So doon natin siya na. Okay, after getting this value using the areas under the normal curve, we're going to subtract it from 5/10, and their difference will be 681 100,000. And since the test is two-tailed, we're going to multiply that difference by 2, and the product will be 1,362 10,000. So thus, the p-value is equal to 1,362 10,000. So since our p-value is greater than the level of significance, again, our level of significance is 500s, so this is obviously greater than to 500s, we do not reject the null hypothesis. So our conclusion is the same from the the first method that we use, which is the critical value method, that the average weight of the babies of birth is 3 and 4/10 kilograms. So meaning the null hypothesis is accepted. Test the following hypothesis using the given information. So our given are already listed here. So the null hypothesis is mean equals 84, alternative hypothesis is not equal to 84, and our level of significance under type 1 error is 500, and our sample mean is equal to 87, while the population standard deviation is equal to 10, and sample size equals 35. So we're going to have the solution through critical value method, and we're going to use the Z statistic. So why? Because our standard deviation is definitely greater than 30 and our variance is known. So by substitution, we're going to have the solution 87 minus 84 over 10 divided by the square root of 35, and by performing the operations, we're going to obtain 1 and 77/100. And this is the value that corresponds our claim. So next, we need to know the critical values, and since our alternative hypothesis is not equal to 84 and this unequal sign falls under non-directional, we're going to use the two-tailed test. And by the given level of significance, which is 500, and again this is two-tailed, we all know that the critical values, we solved it earlier twice already, will fall under to positive and negative 1 and 9600. So this will be our critical values. So again, recap, any number that is greater than positive 1 and 9600 will fall under the rejectional region, while any number that falls or less than to negative 1 and 9600 will fall to the rejectional region. And between the interval of negative 1 and 9600 and positive 1 and 9600, that will be fall to the acceptance region or non-rejectional region. So since our Z statistic is 1 and 77/100, and definitely it will fall within the acceptance region, so our conclusion will be accept the null hypothesis. To test again the following hypothesis using the given information. Null hypothesis, mean is equal to 40. Alternative hypothesis, mean is less than 40, and the level of significance is 500. Sample mean is 37. Population standard deviation is 8 and 5/10, while sample size equals 52. So this time, we're going to use the p-value method, and again, we're going to use the Z statistic. Why? Because our n is greater than 30 and the variance is known. So in this problem, we're just going to substitute the given values. So that is 37 minus 40 divided by 8 and 5/10 divided by the square root of 52. So performing again the operations, we're going to obtain negative 2 and 5500. So that will be our Z statistic. Okay, so this is the value that's being claimed by our givens. So since again H sub A rather, or our alternative hypothesis is directional. Why directional? Because this time we use the symbol of less than. So directional meaning we're just going to use the one-tailed test. So since again our Z statistic is negative 2 and 5500, the area is 4,946 10,000s, and by subtracting it, we have 5/10 minus 4,946 10,000s, it will result to 54 10,000s. And since the test is one-tailed, no need to double the result. We're just going to do this kapag two-tailed siya. So thus, our p-value is equal to 54 10,000s. And since our p-value is equal to 54 10,000s, and this is less than our level of significance, again, our level of significance is 500. So our conclusion is to reject the null hypothesis. Just to show you where is the area came from earlier dun sa ating solution. So we have the Z statistic of negative 2 and 5500s. So regardless of its symbol, we need to find what is the corresponding area under 2 and 55 hundredths. So you're just going to look after the 2 and 5 tenths here. Then we have the 5 hundredths. Just add and look after where is the area that is being claimed. So that is 4,146 hundredths. Example. So it is claimed that the average age of working students in certain university is 35 years, and the researchers selected a random sample of 25 working students. The computation of their ages resulted to 32 years with a standard deviation of 10 years. Does this mean that the average age of the working student is different from 35 years? So use 500's level of significance and assume normality in the population. So we're going to have a solution based on the critical value method. So for our null hypothesis, that would be equal to 35, or our mean will be equal to 35. Our alternative hypothesis will be not equal to